Video 7. Importing data from a database. Previously we learned importing data from a JSON resource. In this video we're going to take a look at installing SQLite library, running query against selected tables and reading the result returned from the database engine. We most often use the already produced data rather than producing the data ourselves. A modern application, for example, holds different datasets inside relational databases, or other databases like MongoDB, and we use these databases to produce beautiful graphs. We'll use a SQLite database because it requires the least effort to set up, but the interface is similar to most other SQL-based database engines. This example uses simple SQL language and should be reproducible on most common SQL database engines. To be able to execute this example, we need to install the SQLite library. Python support for SQLite is available by default, so we don't need to install anything Python related. Just fire this code snippet in IPython to verify that everything is present. We get an output similar to this as shown here. Here, SQLite 3.version gets us the version of the Python SQLite 3 module, that is 2.6.0, and SQLite_version returns the SQLite library version. To be able to read from the database, we need to perform these steps. First, connect to the database engine, or the file in the case of SQLite. Then run the query against the selected tables. And lastly, read the result returned from the database engine. First, we need to import this SQL file into the SQLite database. Here's the code on how to do it. This reads the SQL file and executes the SQL statements against the opened SQLite DB file. If we don't specify the file name, SQLite creates the database in memory. The statements are then executed line by line. If we encounter any errors, we catch exceptions and print the error message to the user. After we've imported data into the database, we're able to query the data and do some processing. Here's the code to read the data from the database file. Just for the purpose of clarity, I'll explain the SQL query in this code sample. ID, name and population are columns, fields of the table city from which we select data. Order by tells the database engine to sort our data by the population column, and DESC means descending order. Limit allows us to get just the first 1,000 records found. For this example, we have used the world.sql example table, which holds the world's city names and populations. This table has more than 5,000 entries. First, we verify that the user has provided the database file path. This is just a quick check to ensure that we can proceed with the rest of the code. Then we try to connect to the database. If that fails, we catch SQLite 3.error and print it to the user. If the connection is successful, we obtain a cursor using con.cursor function. A cursor is an iterator-like structure that enables us to traverse records of the result set returned from a database. We define a query that we execute over the connection, and we fetch the result set using cur.fetch all function. Had we expected just one result, we would have used just fetch one function. List comprehension over cur.description allows us to obtain column names. Description is just a read-only attribute and returns more than we need for just column names, so we just fetch the first item from every column's 7th item tuple. Then we use simple string formatting to print the header of our table with column names. After that, we iterate over results, set and print every row in a similar manner. First, let's run the SQLite import code. Then we run SQLite read program. We're reading from world.database file. We've obtained ID, name and population of the cities. Awesome! Databases are the most common sources of data today. We could not present everything in this short video, but we can suggest you where to look for more information. The official Python documentation is the first place to look for an explanation on how to work with databases. The most common databases are open source databases such as MySQL, PostgreSQL and SQLite, and on the other end of the spectrum there are enterprise database systems such as MS SQL, Oracle and Sybase. Most Python has support for them and the interface is abstracted always, so you don't have to change your program if your underlying database changes, but some tweaks may be required. It depends on whether you have used the specifics of a particular database system. In this video, we've learned how to import data from a database. Amazing. In the next video, we'll learn about cleaning up data from outliers.